Hey, so what's up, you guys? My name is Vish, and I will be discussing my senior project research with you guys. It was on network concepts. So first thing first, what are network concepts? So nowadays we have computers with multiple cores, and we have concepts like multiple threading in progress. We're working with that kind of stuff. So what network concepts is basically when you have multiple cores, how those different CPUs, how different parts of the computer talk to each other, and they need to talk to each other. It's like, let's take an example for McDonald's. When you place an order at McDonald's, someone else take the order, they give that order to someone else, they make that order, and then they hand it over to someone else, and they hand it over to you. So all, like, there are different components involved. All they do is via communicating with each other. And here, if you look at the bottom of the slide, there are four cores, and on the left side, those cores, like all cores, are talking to each other. In that process, that's a really complicated process, but that's really efficient because every core, if they're working with each other, they can talk to each other. So it's really good in performance, but it's really costly. And if you look on the right side, there are four cores, but only two cores are talking to each other. So this way, this is a cheap way of communicating with the two things when can communicate with each other, but the performance is really slow in that case. So network on chips is a really vast concept, but that's all you guys need to know to understand my project, what I'm doing. So my project, what is my project? So basically, my project is we're gonna design a module that can receive an input from the user or from any other component, and it will send it to some other another module that will receive the input from the other module. So basically, this is like, let's look at the example. So basically, our my approach is this: we're gonna have a transmitter and a receiver. They'll be a part of a big module. We'll give the input to the module, and inside the module, transmitter will receive that input, will give it to the receiver, and receiver will give it to someone else. Basically, this is how two processes will communicate with each other using transmitter and receiver. So in order to make it much easier, what I'm trying to say, let's do an analogy. Let's say I have a burger and you want that burger. I can just hand it over to you and you can receive it. So basically, that's what we're doing. I'll make a burger, that'll be my input, I'll be the transmitter, you'll be the receiver. Once I have the input, I'll hand it over to you, you'll receive it. And that's what the basic approach is. That's what we are trying to implement. That if I receive an input, I'll keep it and give it to you, you'll receive that input and you give it to someone else. Okay, so in order to do that, there is a protocol called handshaking protocol. So what handshaking protocol is basically, so let's say, if I give you something, how will I know you receive it? I need a confirmation from you. So basically, that's what handshaking protocol is. If you look at this example, if this on the figure, we can see that transmitter is sending something to the receiver, and receiver is sending something back to the transmitter. So basically, they're shaking hands and saying like, okay, I give you this and I receive this from you. Like basically, it's a verbal, like a contract kind of thing, if that makes sense. To make it more simple, what handshaking protocol is, let's say I own a fast food restaurant and you order a hamburger from me and I give you the receipt and I went back to start making the hamburger. So according to handshake protocol, whenever I hand you over the burger, I need you to give me the receipt. So basically, this is what handshaking protocol is. If I hand you over the burger, I want to see the receipt first to make sure that this burger, you're receiving it, you owns the burger, like you'll do it. So basically, if transmitters will send input a packet to the receiver, it wants an confirmation, an acknowledgement signal back from the receiver. Okay, so this is the basic design of my transmitter. It will have four inputs. The first input will be input packet. The other input will be acknowledgement signal. Because of the handshaking process, it needs some acknowledgement back. Then it'll have clock and reset. So the idea of having a clock and reset is basically to keep the transmitter and receiver, actually the whole module, in sync, so that everything goes with the falling edge of clock. And if I want to stop everything and reset everything, I can just press the reset button. So these are the four inputs, and the two outputs will be packet and request. transmitter is pretty simple. It doesn't do anything. Like, we don't have to go in detail what inside is happening, but the basic idea of transmitter is I give transmitter and an input, it'll receive that input, and it will send that input as an output from itself. And that output will go as PKT or packet. But here's the thing, once that output goes outside from the transmitter, that means once the PKT is ready, it will also send a request signal, because I want to tell, like, basically request signal is more like, hey, I'm sending this packet over and I want a confirmation if you receive the packet. It's like, you know how we send those certified mails? Like once the receiver receives it, we get a post back from the USPS. So it's like request, we are sending a certified mail. So request is basically like a certified mail, sending it to the receiver. And receiver, its structure is similar to that of transmitter. The only difference is instead, like in the transmitter, we have a request signal going out and acknowledgement signal going in. In the receiver, we'll have the request signal going in and the acknowledgement going out. So, and we have clock and reset again, basically to keep everything in sync. A receiver will receive some packet from transmitter. It can be any transmitter. Once it receives the packet, it'll try to send that packet as the output packet to the user. But it will also receive a request signal. This means once it receives a request signal, it has to send a confirmation that it received the packet. So this ACK signal, acknowledgement signal, will only turn on once it receives a packet, it receives a request, and that packet is transferred to the output packet. That's only when the receiver will generate an acknowledgement signal. But we do have a limitation in this whole idea. So the whole idea is I get something, I give it to you, and that's it. That's the whole module. But here's the thing. What if you are not available? What if receiver doesn't have enough capacity, or receiver is not ready to receive anything? What will we do? Transmitter is ready to send, but receiver is not ready for any reason. It can be any reason. What if it's not ready? So it's like give and take. Like, for example, for an analogy, let's say I'm trying to give you a burger, but your hands are occupied. What will I do? What should I do? So the solution to that will be a buffer. Let's say, like, for example, let's do the analogy back to make you understand how buffer we will use this buffer. So basically, I'm a McDonald's host. Let's say I'm a server, and I'm trying to give you something like a burger. And with my right hand, I'm giving you the burger. With my left hand, I'm trying to receive the receipt. But we only have two hands. What if I also want to give you a side of French fries? How can I do that? What's the solution? So when we go to a restaurant and we have more than one stuff, how do we take that? How we take many stuff at the same time? We use a plate, right? So we can stack many things in a plate and hand it over at once. So that was the idea of that. That was the solution, basically. That's how we got this idea of the solution. So we will be using a buffer. Basically, a buffer will store as many input packets as we want it to store, and will only send the out when the receiver is ready. So basically, if transmitter is sending inputs and the receiver is not ready, we can just add a buffer in between, and transmitter can keep sending the inputs to the buffer. Buffer will keep storing them. And once it's like, and once the receiver is ready, it will start sending the inputs out one by one. So that was the idea. And we use this all the time. Let's say if you go in a restaurant and let's say if you have, like, you order appetizer, you order salad, you order an entrees, you order dessert. You don't eat everything together. You have a table in front of you. They keep putting stuff on the table, and you can pick whatever you need at first. So that's how we're gonna do it. That's a solution to our problem. If a receiver is not ready, we can just introduce a table in between them, so transmitter can keep putting stuff on the table, and receiver will start picking up from the table whenever it's ready. Okay, so this is how my circular buffer looks like at this point. If you look back here at this example, there are two pointers in the buffer, head and tail. Let me explain how head and tail will work. So basically in the beginning, when the buffer is empty, if you look at the C figure, so both head and tail will be pointing at the same time, at the same slot. But once there is an input, the head will move to the next empty slot. So let's say I have the first packet is number 1. This position will get filled with number 1. After this position is filled, the blue dot will move to the next slot, the next empty slot. So this means the head pointer will tell us where to put the stuff in. So head will keep pointing to the next available slot in the buffer, and the tail will stay at the position which was the first input that we entered. So if we entered the first packet into the second slot, tail will point at the second slot. And let's say the second input was entered to the third slot. Still, the tail will stay on the second slot. But once the second slot is empty, or we take whatever in the second slot was out of the buffer, then the tail will move to the next position, next slot that was filled first, if that makes sense. If not, you can ask me questions later. So that's why we have 2 pointers, head and tail, inside our buffer. Our buffer will have 4 input signals and 2 output signals. So the first will be packet. So basically it will get packet from the transmitter and keep just, okay, the other 2 signals are clock and reset. Clock and reset are just there to keep everything in sync. Then we have a go input signal. So what go input signal is, it basically is an request signal that we will get from the transmitter. So this request signal we called it as a go input signal in our buffer. So basically it tells the buffer that, hey, because buffer doesn't know when the packet is there. So it needs someone to tell it, be like, hey, input is here. Start putting the input inside the slots. So basically go input is like telling buffer like, hey, but there is a packet, put it somewhere. It's like that. The go input signal is like that. And then we have output signals. We have the packet. First of all, the packet will go out, like whatever the packet was. Then we have a valid output signal. Valid output signal is again like go input signal. Like it will tell the next component, the receiver, that, hey, I sent you a packet, so get ready to store that, or whatever you have to do with it. So that's the valid output. And there is a third output signal. Those are the flags. So basically flags are like a way to indicate me what's the status of my buffer. If the buffer is empty, flag will tell me like, hey, the buffer is empty. If the buffer is full, there's no more slot, it will tell me like, hey, buffer is full, or it's almost empty, or it's almost full. So that's my basic design of my buffer. And that's how my module looks like. It's just a bad drawing at this point, but I have a module 1, which is colored in green. That module contains the buffer and the receiver, and that whole module is connected to the transmitter. And the whole thing is itself a big module that's connected to clock and reset. But like there's a detailed explanation of this. Let's look at this diagram. So what I will give this input to the transmitter. Once the transmitter receives this input, it will generate a request signal, and it will convert this input to a packet and send it to the buffer. Buffer will receive the packet, but buffer won't do anything with the packet unless it receives a request or go input signal. Once it receives that, it will start saving those packets inside it. Okay. And once the buffer is full, like it has no more slots to fill, it will send a signal to the receiver, be like, hey, I'm gonna start sending stuff out now, so be ready. So once the buffer is full, it will start sending out the packets to the receiver. It will also send a request signal to the receiver saying like, there's a packet incoming, so get ready. So once the receiver receives that signal, it will take whatever the packet is and send that packet as output. Once it sends that packet as output, it will send an acknowledgement signal back to the transmitter saying, hey, remember couple of cycles ago you sent me a packet? I sent that packet out to the user back again. So that's how my module works. I designed each and every component of these in VHDL. And this is my simulation at this point. So you can look, there is an input going on in the third row of the waveform. There's an input going on, and the output is similar to the input, Like for the first in the first half of the waveform, you can see there is a lag, and you might be thinking why there is a big like lag, because after the other half of the waveform, everything seemed consistent. The difference between input and output is 2 cycles. If you look at here, it's only 2 cycle difference. But before this, there is a big gap. And to my best knowledge, I think it's because my buffer has to wait to get full first in order to start sending things out. That might be one of the reasons, but I'm still trying to figure out why there is a gap in my input and output, like in the beginning. And to sum everything up is I designed a way in which, not designed, like, yeah, let's say, yeah, I designed a way in which I can send and receive I can send information to a module. It will come out from the other end, and there will be a communication between the modules, this to keep everything in sync. And yeah, that was my the research. And I wish I could show you my waveform in live view, but my desktop is not working for some reason. I'm still trying to work on it, and my VHDL doesn't work on my MacBook, so I cannot show you that, but I promise you it works. So that's it.